Okay, for our geometric vectors, we're going to be putting these vector models onto some geometric shapes, typically triangles and parallelograms. So the biggest concern is to make sure whenever you are considering something to be equal, it has to have the same magnitude and direction. Direction is important. And then also your resultant has to be where you started and end where you finished. So, looking at our first triangle, A, B, C, A. Okay, calm down. A to B is vector U, B to C is V, and then A to C is W. Notice where those arrows are. Okay, so I want to write an expression for W in terms of U and V. So if I want W to be the answer, that means I had to start here and end here. Well, it's already drawn perfectly for me. U plus V will equal W. So there's our expression. Okay, so let's look at BC plus CA. Let's add these together. BC plus CA, so I'm ignoring the arrows because the way that it listed the letters, that's the way it wants the arrow drawn. So BC plus CA, where'd you start? B. Where'd you finish? A. Your answer is BA. The notation for vector is like half an arrow there. Let me zoom in so you can see it, sorry. Okay, who is this in terms of U? Well, U is A to B. So if we're saying BA, that will be a negative U. And then in terms of W and V, so how can I add these or subtract these to create BA? So that means I need to go, again, BC to CA, so that's normal V. And if I'm going CA, that's W backwards, so minus W. Each of these pieces will give us vector BA. Cool. Okay, looking at it on this triangle, it tells us that U is A to B, V is A to P, W is AC, P is the midpoint, which means these pieces are equal. Find an expression for V in terms of U and W. Okay, so I need my answer to equal V. It told me that these two pieces were congruent because if I drew the other side, that would make this a parallelogram. Because there's nothing I can do with U and W to create V, because I would need to say U plus BP to create V. However, let's go all the way across, because if this is W, that means this will also be W because they're the same magnitude and direction. So if I say U plus W, that would equal 2V, okay, because we went all the way across. But if you just want 1V, let's basically divide by that too. V. And we did it. Now we're in this true-false section. So they gave us different equations and we have to determine whether they are true or false based on our picture. So remember, magnitude and direction. So DC, I like to use a pencil on this, actually draw it, and then erase for each question. So D to C is here. From C to X, that's here, connect head to tail. Does that equal DX? Yeah, that's where we started. Here's where we finished. True. All right, next question. Does XB equal XD? So here's XB, here's XD. These are equal. They have the same magnitude, but do they have the same direction? No. So that's why this is false. For vectors to be equal, they have to have the same magnitude and direction. Okay. XD is here. XB, okay, XB is right here, but I need to connect these head to tail. So I basically get to shift XB right here. So basically I just took my vector and shifted it up. And it says the answer is 0. This is true because we ended where we started. The displacement is 0. 2xb. Okay, I'm going to be kind of strategic here. 2xb would be like this. It is also like this. We're going the same direction. I doubled it. Is that db? Yeah. Okay, BA plus AD equals BD. True. Let me show you a little shortcut. When you're adding, if these two middle letters are the same, they basically can cancel out. Your answer is the first and the last. Cool, right? DC plus CB. So let's use that trick. This C's will cancel, D to B. True. Let's check on our picture. DC plus CB is answer D to B. Cool. Okay. AX plus XB plus DA. Okay. DA is right here. If I am adding these vectors, I can't add it right here. I have to add it head to tail. So here. Regardless, my answer is not 0. So remember, we can move the vector as long as it has the same magnitude and direction. Okay, when you are subtracting, let me show you how to do it first before I show you the shortcut. So if I have BD, that is here. Subtracting AD, so AD goes up. Instead of subtracting it, or instead of adding it, going up, we subtract it, so we go down. So subtracting AD is the same thing as adding DA, which is basically what we did here. So BD plus DA is BA. True. Okay, 2dx, that would basically be D to B. 2dx plus BC should be DC. Is that what they said? Yes. And last one, BA plus DA, so I'm gonna draw it here, should be CA. Okay, we are off our parallelogram. So I shifted DA, so that would be head to tail. Well, my answer is this vector, where I started to where I finished. Well, who is this vector on our picture? That is CA. So even though it's not on the parallelogram, it is true because it has the same magnitude and direction as CA. Okay, this next section on page 10 is a little bit tricky. We're still doing true, false, but instead of telling us the direction in the equation, so instead of saying like AB, they give us the letter. So we have to look at the picture to figure out the direction. So looking at if they gave us A, we know A is going up. So I have to be careful here. So if I want A plus B. A plus B, okay, those are looking great. They're connected head to tail. My answer has to be from the start of A to the end of B. That is F. F is pointing in the right direction, so that is true. For this one, K plus G, those are connected correctly. I don't have to redraw anything. The answer is F. That's where it's located, but this one is false because the direction is wrong. It has to start here and end at G, but F is pointing this way, so the wrong direction. All right, D minus, so it equals C. I'm gonna start with D minus E. So here's D. Plus E would be this way. So minus E, great, is way over here. Plus F, F goes this way. So from here, head to tail. My answer is this long section, which I don't know what it is, but it's not C. Let me erase. Oh no, oh no. Okay, it's fine. Okay, G is going left plus H, so I'll go left some more. So we can agree G plus H is this whole section. Okay, from here plus E So that's here. I don't know what it is, but it's not little d. Okay. E plus d. So E is here, D will be here. So my answer is this. Is that G plus H? Those are both going left. They are the same magnitude, so we are good. That's true. Okay, A plus B. A plus B, great. Plus K, great. Plus G, great. I'm back where I started. That is 0. H minus C. So if I go H, C is going down to the right, so I need to go up and to the left, basically. My answer would be this. Is that G minus F? So here's G. F goes up, so if I'm going to subtract it, I'll go down. So my answer is this. These might have the same magnitude, we don't know, but they for sure don't have the same direction, so false. Wow, this is just like so much fun. Okay, oh, we have a bunch of stuff. Hopefully it equals 0. So let's start. A plus B plus C plus H plus G. Am I back where I started? Heck yes, we are. True. Cool. Okay, using the same diagram, we're going to find an equivalent vector. So tell me who is equal to 2xd. Tell me who is negative AC. So if I'm going to do 2xd's, that means I'm going twice as long as xd and this same upward direction. So that would be BD. Negative AC is a positive CA. For negatives, you just flip it. And CD minus DA, remember if you're subtracting, you add and then flip the second one. So we're gonna have to look at this. So let me erase what we did last time. So CD is here. AD is here. So I'm gonna throw it like this. My answer is this vector. Who does that match on my picture? B to D. Yay! Okay, this is the last section that we're gonna look at today. Same concept, say true or false based on the picture, but we threw in some magnitudes, threw in some parentheses, threw in some fractions. Things are getting crazy. Okay, BC plus BA. Here's BC. If you're gonna add BA, I can't draw it here. So its equivalent vector is CD, so I'll draw it here. My answer is from B to D, true. Okay, this next section is magnitude. So specifically the length. So I'm not trying to connect anything. So let's like give it numbers. Let's say these are 3 and these are 2. Cool, fun. So BC, its magnitude would be 2, and I just made up these numbers. BA would be 3. That means BD should equal 5. I don't know what BD equals, but I do know that to get this side of a triangle, I don't just add 3 plus 2. So we'll say false. Okay, is AO equal to AC? Remember, to equal each other, they have to have the same magnitude and direction. So here's AO, here's AC. They have the same direction, but different magnitudes. Okay, AB, CD goes back this way. Its equivalent vector is BA, so we are back where we started. Again, you are trying to connect head to tail, so if your vector that they actually name isn't connected head to tail, you have to find its equivalent vector. Is AO equal to OC? They're the same direction, they're the same magnitude, so true. Okay, is AO half of AC? So here's AO, here's AC, they're going the same direction, but it's just cut in half. Great. This one's so fun. All right, when I do parentheses, let's just do what's happening in the parentheses first. Remember our little shortcut, ignore the middle letters if they're the same. So all we have to do is AC plus CD. Oh my gosh, ignore the middle letters. AD, true. I didn't have to look at my picture. Okay, same thing here. We have AB. We can cancel these letters. So plus BD. Oh my gosh, cancel these letters. True. We didn't have to look at the picture. If you would like to look at the picture to double check, please do. But if your letters are the same and you're adding, they can cancel and put together the beginning and the end. The second part is in Schoology for your homework. So please do it here and then input your answers on Schoology. See you sometime soon.